that we're going to have you do today. Ms. Reinwald is going to take small groups of you over to the engineering lab to work on printing your designs for your hair carts. And we think maybe if we do it in smaller groups, it'll be more efficient and effective because then everybody can kind of do something. And that means that I'm going to give everybody instructions right now for what you're going to do in here. And then some of you are going to go somewhere else and do something else, and you'll come back here when you're done. So what I want to make sure is that everybody's really plugged into what I'm going to ask you to be doing and thinking about. So let me just give you a quick demonstration, because I think this is going to be, the demonstration itself is going to be relatively straightforward. And I think that it'll give you kind of an idea of the sorts of things that you can think about. So let's take some carts here. So I have this cart, these two. All right. And so what I'm going to do is I'm going to roll these carts into each other, and what you're going to see is that that what happens with these carts when they collide with each other is interesting. It's going to be interesting in a bunch of ways. So one way is pretty easy, for example, to, like, if we start with one cart motionless and one cart that's moving, then we kind of there's a little switcheroo that happens, okay? And that seems to work pretty effectively. But if we add some mass to one of the carts, then things look a little different. And if we have both carts moving, then things look a little different. We have both carts moving in the same direction, things look a little different. There's all sorts of interesting things that you can see with these carts. And beyond that, there's all sorts of things that I think you're probably not intuitively going to be able to predict. So for example, watch what happens here. Yeah?
Could you move them both at each other at the same speed when they don't have any weight on them?
Yeah. And I think you can probably guess what's going to happen. Guess what's going to happen. Right. They're going to bounce apart, right? Boom.
Cool.
Boom. Boom. Same thing over and over and over. It works every time, doesn't it? Because these carts are all the same. And so we can even swap them out, right? So this one cart, I was rolling that one, and now I just put this other one, make sure that it rolls. Okay, what's going to happen here?
Wait, what did you do?
I just switched carts. I'm going to do the same thing now. So what's going to happen? We'll roll them together. What's going to happen?
They're going to bounce off each other.
They're going to bounce off each other.
Ooh.
Okay, hang on. It's always funny when things don't work as intended. Okay, let's try it again.
Magnet.
So that's interesting, isn't it? Because they're not all the same, are they? Yeah, so we have some that have magnets, and we know that magnets like do stuff. So I have the same Velcro design here. Magnet carts bounce apart and keep moving. If I take one of those carts and I switch it for one without a magnet, that didn't work super well, then they stick together. And what if we start adding mass? Now what? What's going to happen now? They still stick together. What if I just move this one? They still stick together. So there are a whole bunch of things that you can do with carts. We have two different kinds of carts. We have magnetic carts that won't stick together, and we have non-magnetic carts that could potentially stick together. Now, if you might find that if you set the carts up right, the non-magnetic, these are two non-magnetic ones, but they still aren't going to stick together because this one has this spring in it. So some of them are going to sort of behave as if they were magnetic, even if they're not. And then there's also stuff we can do so these are really old, unfortunately, and so I don't know if I can get this particular one to the video that I want to. I don't know if I can get any of these to work the way that I want to. Oh yeah, there we go. So there's other things that we can do like this. what happens if we get two carts like this, and then we like make a spring, push them apart. So we actually have 3 different cart behaviors we can investigate. They stick together when you push them together. They bounce apart when you push them together. And they have a spring that pushes them. You don't even need to be the one who's pushing. Like now, we can look at behavior like this. If I take some mass and I put it on one of these carts, and then pop the spring, there's things that we can observe. The observations we can make, well, so one thing that we can pretty quickly tell from this is that each individual cart kind of retains its own mass. That's not always true in collisions. In some collisions, pieces of one thing break off and stick to another one. If we took 2 balls of clay and they were kind of loose, like Play-Doh, like a bunch of different kinds of Play-Doh stuck together, and we hugged them at each other, there's a realistic possibility that some part of one of those clay balls will break off and stick to the other one. That happens all the time in real collisions, but the way these carts are designed, they stay intact during a collision. Their mass will not change, but their speeds will, and the direction that the carts travel will change. So here is where I want you to start thinking about, and you don't have to write this down, but what I'm going to ask you to do when you're in here is start thinking about taking some observations, and you're basically going to make 2 sets of observations. One set of observations is before the carts collide, and you get to decide what happens. Okay, so you are going to have some initial, that's not a pen, you're going to have some initial conditions, and those initial conditions will be things like are you going to use magnetic carts? Are they going to be the kind of carts that stick together? Are you going to try to involve the spring at all? Those are all properties of the carts themselves. And then there's another set of conditions that you can change having to do with mass. So we've got 2 carts. So we could adjust the mass of the first cart. We can't make it lighter, but we can make it heavier by putting these bars on there. You can adjust the mass of the second cart. You can make them both heavy. You could make one heavy and one light. You can like mix and match however you want. And then the third set of conditions that you can evaluate is the velocity of each cart. That means how fast it's going and the direction. And you can do that for each cart. Each cart you can push at its own speed, and each cart you can push in its own direction. Now, you all know there are going to be some things that just aren't that interesting. Like if I take these 2 carts and I push them away from each other, okay, that's a pretty easy prediction to make. Or if I push these 2 carts this way, but I push this one faster, then they never hit each other, and so that's a little boring. So you're a little bit limited in terms of the speed and direction, because what we really want to see is what happens when these carts come into contact with each other. But you still have lots of options. You can have one motionless, you could have the other motionless, you could have them both moving toward each other, or you could have them moving in one direction or the other with the one that's behind going faster, right? So we can get collisions in a bunch of different ways, even though there's a couple of things that will not be interesting. If they're moving apart, or if the lead cart is moving faster, that's not an interesting scenario, right? So these are your initial conditions. And then when you think about what you're going to see afterwards, these parts aren't going to change. The carts themselves don't change. If they were sticky before, they're sticky after. If they were magnetic before, they're going to be magnetic afterward. The masses aren't going to change. if one is heavy, one is light, then they're gonna retain that. But the speeds and the directions do. So the observations that we're gonna make have to do with only the speed and direction of each card. And where this is gonna get fun and potentially be interesting for you is that once you have done it a few times, some of you won't even need to do it a few times. Some of you are gonna be ready to dive into this, but where it really gets interesting is you can think about what you think is gonna happen. And you can do that, like this would be sort of an in-between thing where you predict what goes on here. So ideally, what would happen is you'd sort of think about these initial conditions first, and then maybe go straight to some observations. So just try some things out. Once you've tried a few things out, then move to making setting your initial conditions first, then making some predictions, and then testing your predictions by making observations. Here's how, and this is here, I'm not gonna leave this up. I'm gonna encapsulate this in a slightly different way. I'm gonna give you one example of what this could look like, and this is how I generally set these things out, okay? So I'm gonna just make a drawing. I'm not gonna write down, we don't have any numbers, we're not gonna measure speed, we don't have any way of knowing the masses. But what I can do is I can say, for example, I'm gonna have one card moving this way at first, and I'm gonna have this card be still. And this card, I'm gonna have 2 bars on the top, and I'm gonna have it moving kind of slowly. And I'm gonna have these be both magnetic cards. So I'm gonna have a magnetic card here, and a magnetic card here. That's all my initial conditions. The type of card is here, they're both magnetic. The mass of each card is here. This one is just a plain card, this one has 2 of the metal bars. And the speed and direction of each card is here. These are my initial conditions. And now, I'm gonna make a prediction. My prediction is this heavy card, I think it's gonna bounce off and go in the other direction. So I think after the collision, my heavy card is gonna go this way, and this card is just gonna stay motionless. So they're still magnetic. The masses, the relative masses are still the same, but I think basically it's just gonna be like this when it hits a wall, okay? So let's try it and see. This card is, neither of these cards is magnetic, so I need my 2 magnetic cards. There's one, oh, that one's magnetic. And here's the other one. And I'm gonna keep this one still. I'm gonna roll this one toward it slowly. What I think is gonna happen is this one's gonna bounce off and go the other direction. Let's see. Well, that is not what happened at all. Let's try that again. Oh, that's weird. This one went a lot faster, didn't it? This one's going real slow. That one goes faster.
Oh wait, it's pushing.
So somehow it got more speed. That's a lot faster. Okay, all right. So here's what it looks like actually happened, is that after the collision, this one, the one with no weight on it, actually went a lot faster. And this one, it seems like, kind of keeps moving a little bit, doesn't it? It doesn't look like it stops. It keeps moving, but it's moving pretty slow now. So this drawing represents my observations. This drawing represents my prediction. And then I can really quickly, in just like half a sentence, evaluate my prediction. Right? I mean, really, my prediction was incorrect. these 4 things is science. This is how science works. We are gonna do this, and we're gonna do this with your air cards. We're gonna add something when you guys are doing it with your air cards, which is we're gonna measure mass, and we're gonna measure velocity, so we're gonna have some numbers. And because of those numbers, we're gonna be able to make numerical predictions about our velocities after the collision. But effectively, this is where we're headed. We are looking to see what happens when 2 moving objects collide with each other. How can we make predictions about it? And so this is what I'm gonna ask you to do repeatedly. This set of initial conditions is one of many, which means this is one of many predictions, this is one of many observations, and your predictions are either gonna be right or wrong. What I want you to do while you're in here is to really engage with what's going on. I want you to be thinking about what your conditions are. I want you to be making thoughtful predictions. It's a game. The game is try to get to the point where every single time your prediction is correct. I want to tell you 2 more things really quickly. The first is some of you are already thinking about careers. And I met a guy about 10 years ago. He's the parent of a student here, actually. Really smart guy. And we were talking, and I asked him what he did for a living. And he said he's a forensic physicist. And I was like, what is a forensic physicist? Basically what happens is insurance companies pay this man to figure out how accidents happen. What he does is he goes out and he makes observations of things like, if there's 2 vehicles that got into a wreck, he looks at where they are, he looks at the angle of their motion, he looks at the degree to which each car suffered like visible damage, and then from that, he can figure out how it must have happened. He knows physics so well that he can work backwards. If you tell him, here's where this car is, here's where this car is, this one is damaged here, this one is damaged here, this one's facing this direction, this one's facing this direction, he'll do a bunch of math, run a bunch of stuff through computers, and he can tell you, that car was speeding. Or, that car was going the speed limit, this one pulled right in front of it. Or, both cars were going the speed limit, this car didn't pull in front, but this guy didn't see him, and he had time to stop, but he didn't. All of those things, he can figure all of it out, and he makes bank. That dude pulls in like 3 times as much money as Reinwald and I combined, and we're the richest people, the 2 of you know. School teachers,
So like
etc.
Yeah, no. Can they reverse the polarity on the carts to see if they get a different result that way?
Absolutely, you should. And what you'll find is some things like work the way you expect and some things don't, and that's okay. Here's the other thing that I want to tell you though, and this is of particular importance to those of you who got D's or F's last semester. I'm on the warpath, not against you, but for you. My goal is to make sure that nobody in this class gets less than a C. That's gonna happen in one of 2 ways. Either you're gonna do what it takes to get a C, which means you're gonna engage with the work that we're doing, you're gonna be using your class time effectively, you're gonna turn in evidence of your work so that we can give you a C, or we will have you removed from the class. I'm not gonna have people in here who aren't willing to do those 3 things. If you are not engaged in learning, if you're not like actively trying to figure stuff out, if you're not giving me something that I can use to give you a grade, then you're wasting your own time. You'll fail, and that doesn't help you, and it doesn't help us either. So we'll find another place. You might not be successful there either, but we already know you're not gonna be successful here if you're not willing to do those things. And I wanna make it perfectly clear that I know everybody in here can do this. So this isn't the kind of thing where it's like, I just can't wait to get rid of some of you. That's not true. I want everybody here at the end of the semester. I want the students who aren't in the classroom right now to be present with us in June with a C or better in Canvas, because everybody should be doing that. I'm asking you to do something that I know you all can do. Be here, use your class time for learning, turn something in so that I can give you a grade. If you didn't do that first semester, it's understandable, right? Like, for some of you. If you don't do that by the end of like next week, this semester, you're gonna be gone. Because what you will be telling us is, yeah, I know exactly what I need to do. I know exactly what will happen if I don't do it, and I'm still not gonna do it. That's a waste of your time, and I'm not gonna waste your time. We'll try something different. I'll keep working with you maybe, like different class, online, independent study, whatever, but you won't be in here anymore if if you're not willing to do those things, or if you're unable to do those things. I know everybody can do it, so it's just a matter of whether you're willing or not, right? So those of you, so Ms. Reinwald is gonna grab some of you right now. You can go to the classroom and do some printing and stuff. Those of you in here, I'll show you where the materials are. I want you to use these silver carts, not the plastic ones. So the carts and the weights and the tracks are all in the back of the classroom, and I'll show you where those are shortly. Ms. Reinwald, do you have anything to add?
If you've already saved onto a USB, how many?
It's what
Like
Angie
3 or
and
4.
Oscar were gathering.
If you've already
You've not
saved,
saved it though.
if you've already saved onto a USB, how much is